All right, hey everybody. We are going to do some review. We're going to do graphing with inequalities, make sure we understand all of the pieces, and then we're going to step it up and we're going to do some graphing of inequalities with a system. So we're going to do more than just one. All right, so whenever you have an inequality, we are going to basically, an inequality is comparing. We're talking about is something greater than, less than, greater than or equal to, or less than or equal to. So if we have a linear inequality, we're going to need to make sure we solve for y, especially if we're graphing it by hand. Now, I will check in Desmos and show you guys some pieces there. But starting with this problem, if we're solving for y, the first thing we're going to do is we are going to subtract x. Now, that leaves me negative 2y is less than negative x plus 6. I always like to put my variable first, so it's in that y equals mx plus b order. Now, here's where you got to remember. When you divide by that negative, if you multiply or divide by a negative, you're going to have to flip that sign. So you're going to have to do the opposite. So right here, I'm dividing by negative 2. Okay, so since I'm dividing by negative 2, we're going to need to change our sign. So it's no longer going to be less than. We're going to change it to greater than. All right, so you've got to remember that. If you multiply or divide by a negative, you're going to need to flip the sign. Now I'm going to simplify this, so I'm going to divide by negative 2 for both of my pieces. So I have y is greater than a negative 1 divided by negative 2 is going to give me positive 1/2 x. And then 6 divided by negative 2 is going to be minus 3. Okay? So just to keep in mind, flip sign when you divide by negative. And you can say multiply as well. You won't multiply as much as you divide, but it still can occur. All right, so at this point, we have a few things happening here. We have a greater than symbol. Now, the greater than symbol, we need to decide on a couple of things. So we have to decide how we're going to shade. So we're going to talk about shading, and we're going to talk about what type of line. Now, the type of line is going to be a solid or a dashed line. Now, in order to be a solid line, if you look at this first piece, okay, solid lines have equal to symbols. That's the reason they're solid. They're included in the answer choices. If they're dashed lines, that means that they're just greater than or less than. That means that it approaches that line, but it never actually is going to equal the line. So for our particular one, we're looking at a dash line. And the reason that we're going to look at a dash line is because we just have greater than. So right here, I have greater than, so we're going to be doing a dash line. All right, so dash is the one we're going with. And then we need to decide shading. Well, if it's greater than, we're going to shade above. If it's less than, then we're going to shade below. So ours is greater than, so we're going to shade above. All right, so at this point, I'm now going to start plotting my points. I'm going to start by plotting my y-intercept, and my y-intercept is at negative 3. And then my slope is 1 over 2. So I'm going to go up 1 and right 2. And I can do that a couple of times to make a distinct line. Up 1, right 2. And like I said earlier, we're going to make a dash line through those points. Okay? And we're going to shade above. Now, when I do shading, just to kind of help myself, I always kind of draw arrows from the line. It's like this is going to be shading above, this is going to be shading below. So those arrows just kind of give me a little bit of guidance to know how to shade. So if we're shading above, then I'm going to shade everything above that line. Now, what does that shading mean? If you have already done those videos for inequalities, then you should have found out that anything in the shaded region is a solution, which means it's true for the inequality. So I could pick the point I think the point for these notes was 0, 0. So they picked the point 0, 0, and they tested it. So they said that 0 minus 2 times 0 is less than 6. Well, 0 minus 0 is 0, and 0 is less than 6. That is a true statement. Okay, I could pick something outside the line. So I'm going to pick a point outside the line this time. And we're going to test that point. So that point is 4, negative 4. So 4, negative 4. If I test that, that's going to be x is 4 minus 2 times negative 4 less than 6. Well, 2 times negative 4 is going to be positive 8. Well, 4 plus 8, that's going to give me 12. 12 is not less than 6. That's not true. That's the reason it doesn't fall in that region. Okay? So given that review, let's look at one of the release questions from the Math 1 EOC. So they give you the problem and it says, which graph does the shaded region represent? Again, they have 2x minus y is less than 4. So we're going to solve that. So I'm going to subtract my 2x, and that gives me negative y is less than negative 2x plus 4. Now, in this situation, I am getting ready to divide by negative. I'm going to divide by negative 1. So that tells me that I need to flip my sign. Okay? So once I simplify this, I get y is greater than, because it was less than, and when I simplify, that's going to be positive 2x minus 4. All right, so we know we're going to have a dash line because there's no equal to, and we're going to be shading above the line. Okay, so if I'm shading above the line, we can get rid of some of our answer choices. Well, the shading here is below the line, so A is not going to work. This one is above, so that's a possibility. This is shading below, so we're going to get rid of C. And D is shading above. So C, B, and D are potential answer choices here. But now I want to check my actual graph, and I'm going to look at the pieces that I have. So I'm going to start with my y-intercept at negative 4. Well, if I look at B, they have a y-intercept at positive 4, so B's not right. Well, look at D. Well, if I continue this line, okay, we got to kind of imagine here, if we continued here, that would kind of put me in that region of negative 4, and then I would go up to over 1, up to over 1, giving me my answer as D. Now, what does it mean to have a system of inequalities? So a system of inequalities is when I have more than one, okay, and I'm going to shade those together. And where those regions overlap, that's where the system is true for both inequalities. So for the first one, again, I'll solve for y. I have 2x plus y is less than 4, so I'm going to subtract 2x. So y is less than negative 2x plus 4. So again, this is less than, so this is going to be shaded below. And there's no equal to, so it's going to be a dash line. All right. And then the next one is less than or equal to, so I'm going to subtract x is less than or equal to negative x plus 9. And again, we're going to divide by that negative. So since we're dividing by that negative, that whole sign needs to flip. So instead of being less than or equal to, it's going to become greater than or equal to. And I'm going to simplify and make this positive 1/3 x. 9 divided by negative 3 is going to be minus 3. Okay? And we're going to graph it. Now you can see that I kind of already have those over here, but for this inequality, it's greater than or equal to, so this is going to be shaded above, and this is going to be solid. I'm actually going to do them in different colors so it's a little bit easier to see. So starting with the first one, I'm going to plot it 4. I'm going to go down to right 1, down to right 1. Now remember, this is a dash line. And we're shading below. So we're going to shade below the line. Okay. And I'm actually going to use the highlighter here to make it a little bit easier for you guys to see. All right, so now we're going to do the second one. So we're going to plot at -3. And I'm going to go up 1, right 3. And that one is going to be a solid line. Now that solid line is shading above. So if we're shading above, now the solutions to these problems are going to be the area where the two regions overlap. So this area right here is the overlap, where the blue and the pink overlap each other. That means that if I picked a point anywhere in that region, it would work for both inequalities. Now, I could pick a point in just the blue region, but it'll only work for that particular inequality. I could pick a point in the pink region, but it would only work for that particular inequality. We need a point that is in the overlap, so it'll work for both of them. So I'm going to pick 0, 0. So if I pick 0, 0, I could plug that into both of them. So 2 times 0 plus 0 is less than 4. So 0 is less than 4, that's true. And then the second one is 0 minus 3 times 0 is less than or equal to 9. And again, 0 is less than or equal to 9. That is also true. So they have to be true for both statements in order for it to work. Okay, so the overlap, where the two inequalities overlap each other, is where it'll work. All right. So another example, if I graph, what would happen, how would I have a no solution for an inequality? And actually, before I go there, let's look at it in Desmos. So again, here is my example in Desmos. So I can see that I could pick a point in that region that is the overlap. I think I did 0, 0 just a second ago, and that point is in the overlap. It has to be where the two shaded regions overlap each other. You can't just pick one, or it won't be true for both of them. Okay, so you can easily graph in Desmos as well, and you can graph it without having to solve for y. So that is a great feature to be able to use. And if I go back to my problem, I'm going to look at an example that has no solution. So graphing the first one, I have 2, and my slope is 1, so I'm going to go up 1 over 1, up 1 over 1. So we're going to shade above here, and it's going to be dashed. Okay. And then the next one is at -1, and we're going to go up 1 over 1, up 1 over 1. Now, if you remember, now this is less than, so it's below. From systems of equations, when they have the same slope, they should be parallel, which happens here with this inequality. They are parallel lines, but the difference is they are being shaded in opposite directions. So there's never a time that they will actually overlap with each other. So this system of inequalities has no solution because they'll never overlap, which means there'll never be a point that works for both of them. All right. So again, a couple of things to remember. If it's shaded above, then it's going to be greater than or equal to. If it's shaded below, it's going to be less than or equal to. If it's dashed, then it's just a greater than or less than. If it's solid, then it's a greater than or equal to, less than or equal to. And then finally, when you're talking about a system of inequalities, you're looking for the overlap. So you're going to have two shaded regions if you have two equations, and where they overlap is where your solution region is.